Welcome to Learning Program 10.5b on the IBM Selectric typewriter. This program gives a detailed, easy-to-trace explanation of how the selective ribbon mechanism works, and also how the correcting tape mechanism works. The objective is to raise your comprehension of these mechanisms to the point where you can troubleshoot and repair them. In other words, by the end of the program, you should be able to trace these mechanisms and localize, diagnose, and correct any malfunctions. The materials you will need are the standard office machine repairman's tool kit with the special tools for the IBM Selectric typewriter, and a Selectric typewriter equipped with a selective ribbon mechanism and the correcting tape feature. You should also have the Selectric adjustment manual and the Selectric service manual. The recommended adjustment manual and service manual are copyrighted property of IBM Corporation. The written questions and suggested answers included with this program will let you evaluate your own grasp of the subject. Any ribbon mechanism has to have at least two features, ribbon lift and ribbon feed. The correcting tape mechanism can be regarded simply as another kind of ribbon mechanism. In both cases, the ribbons are used only once, and the cartridges are discarded with the used ribbon. As a result, these mechanisms do not have a reverse feed feature. The selective ribbon mechanism, however, is capable of operating in two modes of ribbon feed and also two modes of ribbon lift. The regular ribbon lift and regular ribbon feed modes are used with all ribbons that do not have strikeover capability. Strikeover capability, as the name describes, allows the same portion of the ribbon to be used up to 3 times, which permits a much slower feed rate. At the time this course was produced, there were 3 principal types of ribbons available for the Selectric II user. The ribbons are distinguished from one another by their leaders and their pickup spools. The pink leader and pink pickup spool ribbon is regular film ribbon, approximately 120 meters in length. The yellow leader and yellow pickup spool ribbon is for machines equipped with the correcting tape feature. The pink leader and yellow leader ribbons function like normal film carbon ribbons. The blue leader and take-up core ribbon has the strikeover capability. The Tech 3 ribbon cartridge, the cartridge with the blue leader, comes equipped with the tubular protrusion indicated here. When this cartridge is placed onto the selective ribbon mechanism, it changes the ribbon feed rate from approximately 1 millimeter per printed character to approximately 0.16 millimeters per character. It also introduces a small fluctuation in ribbon lift motion, so that all characters print with the same density, without any light sections or dark sections. With these introductory comments out of the way, let us turn our attention to the selective ribbon mechanism. Release the ribbon cartridge by moving the ribbon load lever from right to left, as shown in the frame on the left. Then, before removing the ribbon cartridge from the mechanism, examine the proper way of threading the ribbon. Starting at the ribbon supply spool on the left, the ribbon is placed to the rear of the ribbon shock wire, indicated by the green pencil in the frame on the right. Failure to place the ribbon around the shock wire will cause it to break. The ribbon is then threaded through the ribbon lift guides, one of which is indicated by the yellow pencil. Notice that moving the load lever to the left into its load position lifts the guides and positions the shock wire in a way that greatly facilitates ribbon loading. Furthermore, notice that the knob of the take-up spool cannot be rotated clockwise when the load lever has been placed into the load position. This prevents the operator from inadvertently removing the ribbon slack in the wrong direction during ribbon loading. Now remove the ribbon cartridge by applying simultaneous upward pressure on the left and right ends of the cartridge. Notice the take-up spool ratchet spring, indicated by the green pencil. When the load lever is in the load position, as illustrated here, this ratchet spring is allowed to engage with the teeth on the lower end of the take-up spool, indicated by the blue pencil. When the load lever is allowed to return to its rest position, it uses the shoe indicated by the green pencil to lower the ratchet spring at the point indicated by the blue pencil, keeping the spring disengaged during typing. In order to completely disengage the ratchet spring, it might become necessary to form the shoe indicated by the green pencil up or down. Needless to say, in order to allow good, unobstructed engagement of the ratchet spring with the take-up spool, the spring must be positioned so that it does not touch the take-up spool pivot pin or stem. Allow up to 0.5 millimeter between the ratchet spring and the take-up spool pivot pin. Check these adjustments on your ribbon mechanism before continuing. You will have to temporarily reinstall the ribbon cartridge in order to check the shoe disengagement adjustment. Notice that the lower extremity of the shock wire functions as a very positive lock on the supply spool ratchet at the point indicated by the blue pencil. This means that during ribbon feed operations, the ribbon tension must first be sufficient to disengage this lock. Notice this detail. Only then is the supply spool capable of releasing any unused ribbon. After checking out this locking of the supply spool, remove the supply spool ratchet by taking off the C-clip indicated by the green pencil, and then lifting the ratchet away from the selective ribbon mechanism. Now press down on the point of the load lever latch indicated by the blue pencil. Notice that this action unlocks the load lever by lifting the latch away from the edge of the load lever, the edge being indicated by the green pencil. Move the load lever knob left to right and right to left and study all the parts movements. Make a list of the functions you discover. If your list included rotating the ribbon feed swing arm, which pushes the Wobbler control bell crank to disengage the shock wire, you nailed the top side of the story. And don't forget the underside. The load lever also raises the ribbon lift guides into a convenient position for threading the ribbon. On top of the ribbon bracket, we find that the right-to-left movement of the load lever handle causes counterclockwise rotation, when viewed from above, of the ribbon feed swing arm at the point indicated by the red pencil, against the action of the heavy ribbon feed swing arm spring located in the foreground under the yellow pencil. At the point indicated by the yellow pencil, underneath the large ribbon feed idler gear, the swing arm pushes the Wobbler control bell crank front to left. The Wobbler control bell crank pushes against the upper extension of the Wobbler eccentric, indicated by the green pencil. The movement of the Wobbler eccentric causes the shock wire disengagement lever to disengage the shock wire by acting on it at the point indicated by the blue pencil. Take the time you need to become familiar with the names of these parts. The adjustment sequence for this action requires forming of parts, and seldom, if ever, needs correcting. The sequence is given in frames 273 through 275 of the 1976 edition of the Adjustment Manual, should you wish to investigate it. Underneath the ribbon plate, you will discover that the ribbon cartridge load lever acts upon the ribbon lift bracket in order to place the ribbon lift guides into a convenient position for ribbon threading. The two sources of power used to drive the selective ribbon mechanism are the ribbon feed cam, which is also the detent control cam, indicated by the green pencil, and the ribbon lift cam, indicated by the blue pencil. Take a good look at the ribbon lift cam. You should find that it consists of 3 lobes. This means the ribbon can be lifted to 3 different heights during typing. If you manually cycle the machine through a print operation, you will find that shortly before the end of the cycle, you can obtain this view of the cross-section of the 3 lobes of the ribbon lift cam. The position of the cam follower roller on these lobes is controlled by the ribbon feed wheel, located underneath the ribbon mechanism plate or frame. The ribbon feed wheel can easily be observed from the right side of the ribbon mechanism. The ribbon feed pawl, which comes from the ribbon feed cam follower, is located on the left side of the pivot stud. It engages with the openings in the feed wheel. There are 3 sizes of lobes on the indicated edge of the ribbon feed wheel. In this view, both pencils are located on the left side of the feed wheel. Both pencils point at the same part, namely the ribbon lift control lever, which senses the position of the ribbon feed wheel and, as a result, positions the ribbon lift cam follower roller in line with the appropriate lobe on the ribbon lift cam. At this point, pause the video and hand cycle the machine through at least 6 cycles, observing the movement of the ribbon lift control lever while the machine cycles. Be sure to also locate the ribbon feed pawl. Now move the stencil mode control slider, green pencil, all the way to its stencil position, and observe that through the wing indicated by the yellow pencil, the ribbon lift control lever is rotated front to left, so that at the rear, the ribbon lift cam follower roller is moved all the way to the right, out of the reach of the ribbon lift cam. Furthermore, this new position of the ribbon lift control lever has the additional function of blocking the spring-activated front-to-rear movement of the ribbon feed pawl. The extension indicated by the blue pencil is positioned to the rear of the pivot stud for the feed pawl, indicated by the green pencil. This means that during stencil mode operations, the selective ribbon mechanism will not move. The pivot point for the ribbon lift cam follower is indicated here by the blue pencil. The movement obtained from the cam lobes is transferred to the ribbon lift bracket or ribbon lift arms through the ribbon spread adjusting plate, indicated by the red pencil, and from it to the ribbon height adjusting screw, indicated by the green pencil. The ribbon spread adjusting plate, red pencil, allows us to amplify or reduce the relative motion obtained from the cam lobes by placing the plate closer to or further away from the pivot point of the ribbon lift cam follower, blue pencil. The overall ribbon height is adjusted by the ribbon height adjustment screw, indicated by the green pencil. When you perform these adjustments, first adjust the ribbon height using the medium height lift lobe, making the adjustment so that printing occurs at the center of the ribbon. Then adjust the ribbon spread adjusting plate. In order for the ribbon lift cam follower roller to be moved laterally or sideways, it is necessary to maintain a small clearance between the cam lobes and the cam follower roller during the time the roller is shifted. To establish this condition, the ribbon lift bracket, or arm, is supported at rest by the lug indicated by the red pencil. The ribbon lift cam follower is kept away from the ribbon lift cam lobes by a small spring, the anchor spot of which is indicated by the green pencil. On the right side, the ribbon lift bracket pivots on an adjustable screw, which can be moved left or right in order to minimize the side play of the bracket. That screw is not shown in this frame. On the left side, the ribbon lift bracket pivots around the Wobbler Eccentric, indicated by the red and green pencils. For correctable ribbons, yellow core, and for regular carbon film ribbon, pink core, the Wobbler remains stationary. Only during print operations, using the Tech 3 ribbon, does the Wobbler Eccentric become activated. The purpose of the Wobbler Eccentric is to introduce a small variation in ribbon lift, enabling ribbons with strikeover capability to print with uniform density, as explained earlier. This is needed particularly for operations such as repeat underscore. Without the wobbler, the repeated use of the exact same spot on the ribbon would cause occasional light spots. Let us first examine the ribbon feed mechanism before we conclude the operational theory of the Wobbler Eccentric. The ribbon feed wheel, blue pencil, is made to turn counterclockwise when viewed from above. This torque is transmitted to the ribbon feed shift gear by the flat spot on the ribbon feed wheel pivot post. The flat side on the ribbon feed wheel post is indicated by the red pencil. Notice also that the ribbon feed shift gear is capable of moving downwards when you apply pressure on the nylon disc above the red pencil. This disc is called the ribbon mode button. The ribbon feed shift gear is held in the position shown by a spring located under the gear. The action of the spring is limited by the position of the ring clamp, or clip, visible just below the tip of the red pencil. As you investigate the vertical movement of the ribbon feed shift gear, you may have to relatch the Wobbler Eccentric control bell crank, indicated by the red pencil. This may require clockwise rotation of the indicated Wobbler Eccentric control bell crank against the action of the spring visible under the pencil. Through the aid of two idler gears, or transmission gears, the ribbon feed torque is transmitted from the ribbon feed shift gear to this spiked ribbon feed driver. Notice the sharp spikes on the driver. Through the rather strong action of the ribbon feed swing arm spring, these spikes compress and very tightly wind the used ribbon around the take-up spool. This is very important and necessary, since the used Tech 3 ribbon tends to form a much larger diameter spool when wound up than the unused portion of the same ribbon. This may require forming the swing arm just before the point at which the driver post is fastened to the arm. If this condition of parallelism is not met, the used ribbon may wind up around the take-up spool in a lopsided or cone-shaped fashion, creating excessive friction between the spool and the cartridge housing. In order to minimize the adverse effects of such friction, late model ribbon cartridges are made with wide openings around the spool, as found in the cartridge in the foreground. When the Tech 3 ribbon cartridge is pushed all the way downward, the protrusion inside the cartridge shifts the ribbon feed shift gear from its high position to its low position. The gears shown here, simulated in this view, are the ones that feed the ribbon in that position. In this position, the ribbon feeds at about 0.16 millimeters per printed character. In this position, the ribbon feeds at about 0.16 millimeters per printed character, which yields approximately 630,000 character print operations per Tech 3 ribbon. Activation of the Wobbler Eccentric depends on the use of the Tech 3 ribbon. When the Tech 3 ribbon mode protrusion, or projection, lowers the ribbon feed shift gear, it also lowers the Wobbler Eccentric control bell crank by acting on the lug indicated by the blue pencil. Under spring action, the bell crank rotates counterclockwise. As soon as it disengages from the lug and the ribbon plate, the vertical extension of the bell crank, indicated by the red pencil, eventually interrupts that counterclockwise rotation by meeting the Wobbler Eccentric control cam. From this point on, the position of the Wobbler Eccentric is determined by the position of the Wobbler cam. The Wobbler Eccentric affects the height of the ribbon in the manner illustrated by the pattern in the upper left-hand corner. Now, take the time you need to find the Wobbler cam and trace out the mechanism on your machine, and be sure to familiarize yourself with the names of the parts while you're at it. The cartridge is held down as indicated by the operator. The left side spring is held in position by the pivot screw for the shock wire. The cartridge retaining springs should be positioned so that their vertical leg is flush with the vertical cartridge guide stems. Remember, though, that the retainer spring on the right must also hold the ratchet spring for the ribbon take-up core in its proper position. Check your machine for these conditions. As a final step in the study of the operational theory of the Selectric ribbon mechanism, take a good look at the ribbon lift guides as you move the ribbon load lever back and forth. You should observe that the studs, one of which is indicated by the red pencil, fit into the slots of the guide brackets indicated by the blue pencil. This setup allows the ribbon lift mechanism to rotate the ribbon guides while lifting them. Earlier models moved the ribbon vertically, causing frequent ribbon friction. You should also note that the ribbon lift guides are located at the lower edge of the ribbon. This concludes our discussion of the operational theory of the Selectric ribbon mechanism. Before we disassemble the mechanism to further familiarize ourselves with the parts that are now somewhat obstructed, let's study the operation of the correcting tape mechanism. We'll start by reinstalling the correcting ribbon cartridge onto the Selectric ribbon mechanism of our typewriter. First, let's demonstrate to ourselves how this mechanism works. Assume we were trying to write, the quick brown fox jumps over the lazy dog, and we made a typing error in the word over, forgetting the letter E. We then depress the correction key until we line up the carrier with the letter R when the misspelled character was the last letter printed. A single depression of the correcting key is enough to line up the carrier, since in that case, we need only one backspace operation. To obtain repeat correcting backspace, all we have to do is depress the correction key all the way down. Next, we type the letter R and find that it has been completely erased from the paper, as illustrated here. You will also have noticed that the carrier did not move after this stroke. Now, depress the letter E. Notice that the machine typed the letter E into the space, where we previously had the letter R this time. The machine spaced the carrier, so we can simply continue by depressing the letter R to complete the word over. The great thing about this mechanism is that the operator never needs to lift her hand off the keyboard while performing the correction. After you have tried this out for yourself a few times, take your machine out of the case if you haven't already done so. Also remove the paper pan and the right-hand side dust shield. The depression of the X key, or correction key, performs two functions. The first can easily be verified by looking at the indicated lug of the correction key stem. It overlaps the backspace key stem, causing it to produce a regular backspace operation whenever the correction key is depressed. The correcting key pivots on the adjustable screw pointed out by the red pencil. The pivot point has been made adjustable to enable the serviceman to minimize the side play of the correction key. The link pointed out by the yellow pencil connects the key stem to the correcting mechanism mode latch, located underneath the escapement trigger pawl. This is the correcting mechanism mode lever latch, or simply the correcting mode bell crank latch. This bridge immediately above the mode latch is called the mode actuating bell crank. Whenever the mode actuating bell crank is released, we say the typewriter is in correcting mode. This bell crank carries out 3 distinct functions of the correcting mechanism. 1. To rotate the correcting mechanism torque bar. Can you name the purpose of this link? Take a moment to formulate your answer. If you answered to rotate the correcting mechanism torque bar, congratulations. You might even have answered to preset the correcting tape lift and correcting tape feed action. The torque bar spans the full width of the machine, parallel to the path of the carrier. Therefore, no matter which position the carrier is in at the time the correction key is depressed, any movement experienced by the torque bar can easily be transferred to the carrier components. 2. To deactivate the escapement trigger. What is the purpose of this lug? It receives, so to speak, the restoring motion or force from the escapement trigger support bridge and allows the relatching of the correcting mechanism mode lever, or bell crank. This lug must be formed so that it causes at least 1/4 of 1 millimeter of overthrow for the mode bell crank when relatching occurs. 3. To provide the point of application for the force or motion coming from the escapement trigger pawl. The blue pencil indicates the correcting tape load lever. Notice that when the ribbon cartridge load lever is locked, as indicated by the green pencil, the correcting tape load lever cannot be pushed toward the right, because it too is locked. 2. To activate the escapement trigger support bridge, which returns the correcting mechanism to the typing mode. So, first let's allow the ribbon cartridge load lever to return to rest. The machine is said to be in typing mode whenever it prints characters. It is now possible to rotate the correcting tape load lever into its load position. As you operate the correcting tape load lever, observe and list all of its functions. Take a moment here while you prepare the list. And for that, the correcting mechanism must be inactive and the stencil mode lever must be in the off position. Now we've reached a checkpoint. Be sure to find 3 mechanisms or parts that carry out the functions we have listed. First, we notice that the correcting tape feed sprocket, at the blue pencil, is disengaged from the take-up spool. Second, we notice that the correcting tape guide shoe, at the green pencil, was rotated out of the way of the ribbon. On earlier models of this mechanism, the function of guiding the used-up correcting tape onto the take-up spool was carried out by a guide roller. Third, we notice that the separator wire was rotated away from the card holder. All of these functions are aimed at facilitating correcting tape loading. If you're really observant, you might also have noticed that positioning the correcting tape load lever into the load position locks the ribbon mechanism load lever into its rest position. This way, the operator cannot inadvertently position the ribbon to the rear of the separator wire, since loading of the ribbon cartridge is now impossible. At this point, please remove the correcting tape from the machine. If you said it rotates the correcting mechanism torque bar, congratulations, that's exactly it. And if you went a step further and said it presets the correcting tape lift and feed action, even better. Because the torque bar spans the full width of the machine, that motion reaches the carrier no matter where it sits. If you found 3 things, you got them all. The tape feed sprocket disengages from the take-up spool, the tape guide shoe rotates clear of the ribbon, and the separator wire swings away from the card holder. Every one of them exists to make loading the correcting tape easier, and as a bonus, the lever also locks the ribbon load lever at rest. Before we continue with our studies, let's remove the ribbon mechanism from the carrier. While we remove the ribbon supply ratchet from the machine, it is not really necessary, since there are holes in it that permit the removal of the ribbon plate mounting screws. Next, let's remove the Wobbler eccentric spring completely off the mechanism. Note that the elongated end of the spring hooks onto the Wobbler eccentric. Remove the ribbon lift bracket restoring spring. Again, take it off the machine completely, it will fall off otherwise. The ratchet and the bracket that hold the correcting tape supply spool are called the tape supply cradle assembly, or simply the cradle. Let's examine it. On machines manufactured recently, the position of the fork coming from the cradle is adjustable by the screw indicated by the green pencil. The position of the fork should be adjusted so that it becomes centered with respect to the groove in a pin indicated by the blue pencil. After you have examined the cradle, remove the screw indicated by the green pencil so that the fork can be detached from the cradle. Earlier machines do not have this screw on them. On those, it becomes necessary to manipulate the disengagement and subsequent re-engagement of the fork with the tape lift mechanism during the removal and reinstallation of the ribbon mechanism plate. We are now ready to begin the removal of the ribbon mechanism proper, starting with the removal of the 2 ribbon plate mounting screws. To gain access to the right ribbon plate mounting screw, you will need the ribbon load lever in its rest position, as illustrated here. As you remove the right mounting screw, the ribbon plate will have to come up somewhat. Therefore, first remove the left screw completely so you can lift the plate while removing the right screw. Be extra careful not to damage the ribbon feed gears in the process of extracting the right screw. With your right hand, disengage the correcting tape feed mechanism from the correcting tape feed cam follower by rotating the feed pawl assembly clockwise, as shown. There are a total of 5 points at which we will disengage one mechanism or another. Let us examine each of them. 1. The green pencil points at the engagement between the Wobbler eccentric and the Wobbler eccentric control bell crank. 2. The yellow pencil points at the connection between the correcting tape feed mechanism and its cam follower. 3. At the point indicated by the red pencil, the ribbon lift cam follower roller will become disengaged from its control arm or control lever. 4. At the point indicated by the blue pencil, the tape supply cradle becomes disengaged, as we discussed with the previous slide. The 5th point of disengagement resulting from the ribbon plate removal occurs under the plate, between the ribbon feed pawl and the feed wheel. With this discussion out of the way, it is possible to lift the entire plate away from the carrier. Be careful not to damage the separator wire in the process of disassembling the mechanism. It is now easy to complete the study of the correcting tape mechanism. Occasionally, you may have to go back and forth between the typewriter and the ribbon mechanism as we study it, but we can now see every detail. The yellow pencil points at the torque bar position sensor, specifically the leg which extends downward into the path of the correcting torque bar. Let us take a very close look at the small spring indicated by the blue pencil. The action of the spring can be compared to that of a pair of scissors trying to close its blades. The ends of the spring represent the blades of the scissors, and those so-called blades are connected to the parts indicated by the yellow and red pencils. The red pencil points at the spring connecting lug, which is part of the correcting tape lift arm assembly. The correcting tape is lifted only on this left side of the carrier. The yellow pencil points at a stud which is affixed to the torque bar position sensor. Since the scissor action of the 2 ends of the spring tries to bring these points together at all times, we discover that the point indicated by the red pencil can only move toward the rear of the carrier, toward the platen, until its movement is interrupted, because the slot in the lift arm stops against the stud or screw located directly behind the red pencil. As for the torque bar position sensor, indicated by the yellow pencil, it tries to move toward the front of the machine until it meets the adjustable stop on the correcting tape lift assembly. This means the hex head screw, or stud, which limits the rearward movement of the correcting tape lift assembly, constitutes the fixed point or reference point. The adjustable stop indicated by the blue pencil must be set into a position such that there is only a minimum clearance between the torque bar sensor and the torque bar. However, there should not be any drag on the carrier movement resulting from friction between the torque bar position sensor and the torque bar. This way, the smallest amount of movement of the torque bar can readily be transferred to the sensor. But another question pops up here. What determines the rest position of the correction mechanism, torque bar. On this new style of correcting mechanism, the torque bar should simply be positioned so that its flat edge is vertical. This condition is achieved by adjusting the length of the link, which connects the torque bar to the correction mode actuating lever, which we pointed out earlier. This means that the correcting mode lever is the fixed point for the torque bar position adjustment. We conclude, then, that the position of the torque bar is the fundamental adjustment for the adjustable stop indicated by the blue pencil. Be sure to notice the backup bracket for the torque bar, located underneath the carrier. It too must be adjusted for no friction on the carrier movement. You should repeat this section of the program until you have become thoroughly familiar with its details. Depress the correction key several times and observe the part's movements, taking whatever time you need to work on the machine. Depending upon the level of the correcting tape mechanism on your machine, you may have found that the movement from the torque bar position sensor was transferred further, from the point on the lift arm assembly indicated by the yellow pencil, through the transmission bridge indicated by the blue pencil, to the right side of the carrier. From the transmission bridge, indicated by the yellow pencil, the movement is transmitted on to the correcting tape feed inhibitor, indicated by the blue pencil. As mentioned, this is the configuration of late-level correcting mechanisms. This is the correcting tape feed inhibitor as it is provided on early-level machines. This inhibitor is also a torque bar position sensor. Notice that it extends all the way downward, where, during correction operations, it is acted upon by the correcting mechanism torque bar. The most obvious shortcoming of the early type of correcting mechanism is that it does not have sufficient adjustments to permit an easy fine adjustment of the mechanism. To obtain the minimum clearance between the sensor and the correction mechanism torque bar on this type of sensor, it is necessary to form the lower tip of the sensor. Since this tip is rather hard to reach with forming tools, it was soon superseded by the better-designed later level of correcting tape mechanisms. Now take a close look at the cam follower indicated in the frame on the left. This is the correcting tape lift cam follower. In the frame on the right, showing the leftmost cam on the print sleeve, we have the correcting tape lift cam. Notice that this cam follower is made to oscillate every time the print sleeve rotates through a print cycle, whether the correction key has been depressed or not. When the correction key is depressed, the correcting tape lift arm assembly will slide toward the front of the carrier. As a result, the lift arm latch, indicated by the yellow pencil, will be positioned above and in the path of the correcting tape lift cam follower, indicated by the red pencil. This amounts to the presetting of the correcting tape lift action. The lift arm latch is adjustable horizontally and vertically. When the correction mode latch is restored and at rest, or when the machine is in typing mode, the movement of the correcting tape lift cam follower should clear the lift arm latch by at least 1/4 millimeter. This constitutes the adjustment of the horizontal position of the lift arm latch. When the correction mode lever has been released, or when the machine is in correcting mode, the lift arm assembly, together with the latch, will have moved toward the front of the machine. At that point, the vertical clearance between the lift latch and the cam follower should be a maximum of 1/4 millimeter. But before you make any adjustment changes on your machine, keep watching. The position of the lift arm latch is only a secondary adjustment in this sequence. We must first find and check the fundamental adjustment. Notice that the blue pencil points at the part, or bracket, which holds the rear of the correcting tape lift arm assembly at rest. The correcting tape guide is stopped at rest by the lug indicated by the blue pencil, with a spring located under and behind the yellow pencil doing the holding. This lug is part of the bracket which is held onto the carrier by the screws, one of which is indicated by the yellow pencil. The position of the bracket is adjustable, and needless to say, this is a fundamental adjustment because it connects the bracket to the carrier frame. This bracket must be adjusted so that, at rest, the correcting tape is positioned just below the level at which the underscore would print. This drawing says it best. 0.03 to 0.13 millimeters, or roughly 1/10 millimeter of clearance, should exist between the bracket and the carrier frame. This is the maximum clearance between the top edge of the correcting tape and the underscore. This fundamental, or primary, adjustment has two secondary adjustments. Notice the oblique lug at the bottom of the correcting tape lift bracket. It is responsible for deflecting the velocity control cable when the carrier approaches the extreme left margin, and the rotate arm. This is the first secondary adjustment to be made in connection with the rest position of the correcting tape lift bracket. The other secondary adjustment is the vertical positioning of the correcting tape lift arm latch, which we studied a moment ago. One final and important word about the correcting tape lift arm. When the ribbon lift guide bracket is not positioned properly, it might interfere with the movement of the correcting tape lift arm. It is therefore necessary that there be a clearance of at least 3/4 of 1 millimeter between the path of the correcting tape lift arm and the metal bracket which supports the left ribbon guide. Check this carefully on your machine. Failure to ensure free movement of the correcting tape lift arm will most likely result in a deformed cam follower. In the case of a cam follower deformation, we would have to remove the cam follower from the machine in order to straighten it out again. It cannot be done well without this step. This is the correcting tape feed cam follower. This cam follower will only be able to operate if the inhibitor on the right outside of the carrier has been rotated out of the way of the cam follower. Be sure to take a look at the contour of the correcting tape feed cam. It has two lobes. The first lobe feeds 1/3 of the total feed needed for one operation. During printing, there is no feed action, so as not to affect the velocity of the print sleeve or the velocity of the rocker. After printing has occurred, the second feed cam lobe completes the remaining 2/3 of the feed action. The lobe of this cam follower which comes in contact with the feed inhibitor must be formed vertically, so it clears the inhibitor by approximately 1/10 of 1 millimeter. On early-level machines, through this lobe we also control the clearance between the sensor and the correcting tape torque bar, by forming the lobe front to rear or rear to front as needed. We must always be sure to check the freedom of movement of the inhibitor. It can easily develop a bind. Finally, let us examine the feed pawl and the feed sprocket, indicated by the yellow pencil. During feeding, the feed pawl must overcome the rather heavy friction which holds the sprocket in its position. During the return stroke, the pawl, at the yellow pencil, ratchets over the notches in the sprocket under the action of the spring indicated by the blue pencil. Be sure to remember to hook up the spring during reassembly, since the feed pawl tends to be difficult to reassemble and the spring becomes unhooked every time the mechanism is disassembled. To prevent unwanted clockwise rotation of the take-up spool, the correcting tape mechanism comes equipped with the indicated ratchet spring. Now take some time to study the operation of all of the functions of the correcting tape load lever, such as the rotation of the separator wire. The separator wire should touch the card holder. Again, this is a secondary adjustment, since the position of the card holder must precede the making of the separator wire adjustment. The card holder should be adjusted front to rear so that it is at approximately 0.5 millimeter from the platen. With the multiple copy control lever, in position A, the card holder should be adjusted left to right so that it meets the alignment conditions depicted in this diagram. It is important to know that the slightly fogged appearance of the card holder is due to a Teflon coating, intended to make it harder for the lift-off type of correcting tape to stick onto it. Do not use petroleum-based chemicals to clean the card holder, since they will remove the coating. With the ribbon mechanism out of the machine, it is easy to see that the locking of the ribbon load lever at rest by the rotated correcting tape load lever at the red pencil is not a one-way feature. With the lug indicated by the yellow pencil, the ribbon load lever, when operated, also locks the correcting tape mode lever at rest. Take whatever time you need to inspect this feature. Finally, let us examine the bias springs for the correcting tape supply spool ratchet. The spring indicated by the blue pencil is called the light bias spring. As we rotate the supply spool ratchet counterclockwise, first we must counteract the low bias spring. This spring is intended for use with a Tech 3 cover-up tape, and it is the only one needed when using cover-up tape. The high bias spring will provide high bias, but only with a sticky correcting tape supply spool in position. Place a lift-off tape supply spool onto the ratchet, and then rotate the spool counterclockwise to investigate its operation. As a final step, let us familiarize ourselves with the Wobbler control cam and follower, located to the right and in the general direction of the blue pencil. Let's also familiarize ourselves with the ribbon lift control lever, at the red pencil. The position of the ribbon lift control lever is obviously determined by the ribbon feed cam. Nevertheless, it has to position the ribbon lift cam follower roller into the center of the lobes of the ribbon lift cam. In order to achieve this, it is necessary to form the lever in the region indicated by the red pencil. The ribbon feed cam follower, at the yellow pencil, is adjustable front to rear by loosening the screw indicated by the red pencil, and then positioning the eccentric pivot stud. This adjustment should be set so that during ribbon drive operations, the pawl very slightly overthrows the various positions of the ribbon feed cam. This condition is best illustrated in this drawing. The lateral position of the ribbon feed pawl must be adjusted so that there is up to 1/4 of 1 millimeter of clearance between the pawl and the ribbon feed wheel hub. Of course, this can only be checked when the mechanism is fully assembled. Make sure that you fully understand the ribbon feed mechanism and also the ribbon lift mechanism before we begin reassembling it. To start the reassembly, it is necessary to hold the feed pawl up as shown. Take whatever time you need. Then reinstall the mechanism as demonstrated here. Check the re-engagement between the ribbon lift cam follower roller and the ribbon lift control arm. Next comes the re-engagement between the Wobbler eccentric and the Wobbler control bell crank. The bell crank must also be engaged properly with the ribbon feed shift gear, as illustrated in the frame on the right. Then comes the correcting tape feed mechanism to the driving cam follower. Be sure to hook up the sprocket pawl return spring before you move on. Finally, reinstall the cradle control fork on a provisional basis if you have a new style. If your machine is of an early type, simply make sure the fork is properly engaged with the pin of the tape lift guide. Now reinstall the supporting screws for the ribbon plate. Reinstall the ribbon lift bracket restoring spring. Now hook up the Wobbler eccentric restoring spring. Finally, reinstall the ribbon supply spool ratchet. You will have to swing the shock wire out of the way of the ratchet in order to position the ratchet properly. Now recheck the operation of the various mechanisms. Start with the ribbon mechanism. First, the ribbon load lever and all of its functions. Then ribbon feed. Regular and Tech 3 mode. Now ribbon lift. Regular and Tech 3. Finally, check the position of the ribbon guides and the card holder. Then we turn to the correcting tape mechanism. Again, we start with the load lever, then the X or correction key and the 3 functions of the mode actuating lever or bell crank. Then check the correcting tape lift and correcting tape feed activation. Don't forget the interlock functions. After all this, you should subject your typewriter to a thorough and extensive power-on test. Test each of the functions of the selective ribbon mechanism and each of the functions of the correcting tape mechanism in much the same sequence in which you performed the final checkout. Congratulations on finishing this learning presentation and exercise. We suggest you continue with the written question and answer section so you can complete this learning program. We wish you good luck in the service of Selectric typewriters.